Welcome to Study Loop.
So what we see here is we have a water trough, and our ultimate goal is to find the volume, or ultimately to find how fast the water level is rising. So we want to refer to these values with different equations so we can take the derivative of them. So we know that the volume is going to be equal to the area of the cross section times the length of the trough. So if we have our trough right here, it has some depth like this. And if this is the cross section right here, because this goes all the way through, and then we have the cross section times the length, that'll give us the volume. So we know the length of the trough is given as a constant of 10 meters. So we can differentiate both sides with respect to t. We get dv dt is equal to L times dA dt. So L is 10, so we could just write that as 10 times dA dt. Then we want to find the area of the cross section, which we know is it's an isosceles trapezoid. So if we look for the area of isosceles trapezoid, what we end up getting is the length of the upper base plus the lower base divided by 2 times the height. So we know that the length of the upper base at any time is 2k plus 30. And that's going to be, also we know that the using triangles within our trapezoid, so if this is our trapezoid right here, using this diagram where we have these small triangles with lengths k, this is 30, 30, 30. This is going to be 25 and 25. Then we have right here the height, and then right here is going to be 50. So based on all of this, we know that 25 over k is equal to 50 over h. So knowing that, we see that h is equal to 2k. And therefore, if we have 2k 30, that's the same thing. At 2k plus 30, we could rewrite that as h plus 30. Then we know that the lower base is length 30, so we add that, and then that's going to be over 2 times the height. So another way we could write this now is going to be h squared over 2 plus 30h. And this is helpful because we now have our area, which we can take the derivative of and end up getting that dA dt is equal to h plus 30 times dH dt. Thankfully, though, we can substitute this expression in for the previous equation because our goal is to find dH dt. So we have that dV dt is equal to L times h plus 30 times dH dt. We know the values that we've been given are the volume, so 0.2 meters cubed per minute. And then we also have, since we're dealing with centimeters, the way that we're going to want to write this is 0.2 times 10 to the 6th centimeters cubed per minute. And then we know that since the length is 10, the height is 30. So we have a length of 10 right here and a height of 30. So based on that, we now have that 2 times 10 to the 5th is equal to 6 times 10 to the fourth dH dt. We divide these and we end up getting that dH dt is going to give us 10 centimeters per minute. So that will be our final result, and that's the rate at which the water level is increasing.